Okay, so we can do the same thing when a graph is given to us, right? And they ask us to find the equation. In this case, they've already given us that there's 2 points, and one of them is the vertex. So it's not too bad. Otherwise, you're going to have to kind of locate the point, right? So my vertex, which is h and k, and then x and y is a point. So same thing, y equals ax minus h. Start with the general form. And then plug in the vertex, which is, in this case, what would I plug in? Plus 1, right? Plus 1, because minus and negative gives you a positive. So that's going to be plus 1 squared, and then plus 3. Then you're going to plug again 2 for y, 0 for x. So 2 equals a times 1 squared plus 3. That's going to be 2 equals a plus 3. Bring the 3 over, so that's going to become minus 3, which I will have 2 minus 3 equals to a. And a is negative 1. Does it make sense that a is negative 1? Negative 1 and for what? You're going to get the same answer, but then when you write your final equation, it's going to be wrong, right? This is going to be the same, but this is going to be wrong because this is where your point, this is where would your graph be. So your graph is going to be like this. Is that the same graph? No. Okay. The reason why you're going to get the same answer is because when you do this, negative 1 squared is going to give you positive 1. That's the only reason why. Okay? Does it make sense that my a is negative? Which way does my graph open? Down, right? Down means negative a. What's up? What's wrong?
What if x, y doesn't touch, the parabola doesn't touch y axis? What happens?
It doesn't matter. It could be any point you can pick. So if they didn't give you this point, let's say you could have picked this point. You could have picked this point. You could have picked any point other than the vertex.
So it doesn't matter.
It doesn't matter which point you pick. A point on the graph is sufficient to enter it and then find the answer. What? Did you bring the 3 over as a negative 3? And what's 2 minus 3? Yeah, 1a and a is the same thing, right? This is 1a or a is the same thing.
Yeah, so then I'm dividing.
You divide by 1? You guys, what did we learn yesterday about the vertex? About the h of the vertex. It's opposite to what it is. So if it's negative 1, when you plug it in, it's going to be plus 1. If you don't do that, you're going to be in big trouble. So we're going to just review quickly about what kind of transformation we had and how can we graph. We've already done this. I've already explained it to you. But again, we're going to see it a little bit more, and then we're going to explore it a little bit more. Okay, I've already talked about it. So in my equation, which is my vertex form, what does A do to my graph? So it's a reflection. Okay. What else? No, I'm asking about A.
If it's more than 1, y.
So if it's more than 1, what do we call that?
Stretch.
Vertical stretch, yep. Good. So A represents the direction of opening, so either up or down. Or you know what? I'm going to just put reflection. Okay. And vertical stretch or compression. K, which is the outside part, that's your vertical translation. Because it's not the y-intercept. No, it's not. It's the y value of your vertex. And then H represents what? And the coordinate of the vertex of the parabola are H, K. And then to graph, when they give you the equation, right? To graph, first you're going to, especially when they give it to you in the vertex form, first you're going to locate your vertex, which is the H and K. Then you're going to use your step pattern multiplied by the A value to find your next points. Okay? So, if I want to sketch this, first thing I want to do, I'm not going to do this step by step because using that it is helpful. Okay? So, we're going to just skip to this part. What's my vertex here? Right? Because it's supposed to be x minus h, right? So that minus is already there in the function, right? So h is 3. Make sense? Okay, so the vertex is 3, 5. My regular step pattern are 1, 3, 5. Now, because I have the a value, that's going to affect the step pattern. So remember, step pattern is a times 1, 3, 5. So in this case, my step pattern is -4 times 1, 3, 5, which becomes like this: -4, -12, -20. That means what? I'm going to go down 4 over 1. Down 12 over, 1, right? Down 20 over 1. Now, I might not be able to fit everything, okay? What I need from you is to try at least to fit 5 points, right? So the vertex and then 2 sets, okay? So here it is. First, I'm going to look at the vertex, 3, 5. So 3 is right here. And 5 is 1, 2, 3, 4, 5. So it's right this way. Which way is my graph going to open? Down, because A is negative. Okay? Then I'm going to go down from the vertex. I'm going to go down 4. So I'm going to count 1, 2, 3, 4, and over 1. I know this is not too clear. Let me try to do this. Can you guys see this better? Yeah. All right. So we're going to go down 1, 2, 3, 4, and over 1. So my point is going to be right here. And then over to the other side 1 as well. Okay, then how much do I need to go down for the next one? 12. Let's see if we can fit that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Over 1. So I am going to go all the way down here. Now, does it make sense that my graph is so skinny? Why? New Year resolution? Yes, keep going. Yes, sorry. Yeah.
Because -4, A value is high.
4. The A value is 4, which means you have a vertical stretch, right? Think about the elastic band, yeah? When I have the elastic band, I had to stretch it. It became skinnier. So you have a vertical stretch. You're expecting this. Okay? You see how I have a set of 5 points here? So I have my vertex. Very bad color with this. So I have my vertex, and I have 1 set and then 2 sets. So altogether 5 points, right? This is the least I'm expecting. Okay? Now, if you are going to look at your graph, at your equation, or at your graph, and then you're going to have to name the transformation for me. I'm asking you to state the transformation. What would you say? Okay. So I have a vertical stretch. I said I'll write VS. Yep. I have vertical stretch. And then we have reflection where? In the x-axis, yeah. Okay, what else?
Horizontal translation 5 units to
So horizontal translation, 3 units, right? Yeah. And? Good. Excellent. So you see right here, cheat sheet. It's right there. You want to use it, you're welcome to. You don't want to use it, you don't have to, right? So, horizontal translation is with the H, vertical translation is with the K. A tells you if it's negative, then it's a reflection in the x-axis. And then if it's greater than 1, it's a vertical stretch. If it's between 0 and 1, it's a vertical compression. Are we okay with this? We don't do that with quadratics. Yes, there is. Yes, basically what you would do, let's say if you have something like this and then it's reflected in the y-axis, it becomes like this, where you go, right? Yeah, but we're not talking about that right now.